Hi, welcome. So the problem is maximum subarray sum. Okay, it is a moderate problem. You can see moderate problem and ask in these companies. Amazon, okay, Amazon, Flipkart, Samsung, fine. Microsoft, Google, oh wow, fine. PayPal, Virtusa, Hesden, Deloitte, Tech Systems, Cvent. So three farm companies ask this problem. Okay, and yeah, it's a good problem, subarray sum. Fine. So let's see what problem is saying to us. Okay, what problem want us to do. Given an array of numbers, let me select my pen. Given an array of numbers, find the maximum sum of any contiguous subarray of the array. Okay, fine. So array is given to us as 34. Okay, let's see. 34, this array I'm taking. Okay, 34 minus 50, 42, 14, minus 5, 86. Okay, so now what is subarray? What is subarray? Subarray means a contiguous part of array. Contiguous part of array means okay, 34 is subarray, 34 minus 50 is subarray, 34 is subarray, 34 minus 50, 34 minus 50, 42, 34 minus 50, 42. Okay, 34 minus 50, 42, 14. Fine, 14, then minus 5, then 86. These are subarrays. Now you will be asking me, only these are subarrays? No, these are the subarrays starting from 34. Okay, starting from 34, these are the subarray. How? See here, 34 and then contiguous part. Okay, that means there should not be any gap. Fine, 34, 34 minus 50, 34, 42, 34, 14 till 86. Now subarray starting from minus 50, minus 50, minus 50, 42, minus 50, 14, minus 50, 42, 14, minus 5, minus 50, 42, 14, minus 5, and 86. These are also subarrays. Why? Subarray means contiguous part of array. Contiguous part. Okay, these two are contiguous part. These three are contiguous part. Now you will be asking me, okay, fine. So is 34 minus 5 and 86 are also subarray? 34, one is minus 5 and one is 86. No. Why? Because there is a gap, discontinuity. Okay, this is subsequence. Subsequence and subarray are different things. We will do subsequence problem also, hard, medium, easy. But these are subsequence. It is saying us maximum subarray sum. So it is not subarray. Subarray means a contiguous. It should be continuity. It should maintain continuity, not discontinuous. Okay, fine. So it is not subarray. Okay, let me erase it. It is not subarray. So first set of subarray is this. It is pass 1. Second set start from minus 50. Third set start from 42. This 42. Okay. So if I erase this all, okay, and let me take it to my whiteboard. Okay. So suppose if the array is given to us as, let's take a simple array. Array is 1, 2, 3, 4, and 5. Okay. So subarrays are 1, okay, 1 2, 1 2 3, 1 2 3 4, 1 2 3 4, and 5. These are the subarrays. Okay, pass 1. Now 2 2 3, 2 3 4, 2 3 4 5. These are also subarray because they are also maintaining continuity. 2 2 3 2 3 4 2 2 3 5. Yes, pass 2. Okay, 3 3 4, 3 4 5. These are also subarrays maintaining continuity. Pass 3. 4 4 5. Yes, these are also subarray. And 5. Pass 4, pass 5. Okay, so these are the subarrays. We have understood what is subarray and how many subarrays. Now what question is asking us to do is find the maximum sum of any contiguous subarray of the array. Okay, maximum sum. That means you need to calculate the sum of all these, sum of all these, sum of all these, sum of all this, and you need to find maximum sum. You know point? You need to find maximum sum. Okay. Now we are very clear that what we need to find out. Okay, but we are not clear how to find out. See, my videos are first what. Don't worry about how. I'll explain step by step, then debugging, and then code, then debugging that code also, and then time complexity analysis, a full package. Okay, fine. So we need to find out maximum subarray sum. Before it, we need to find out all the subarrays. Okay. Now, very first thing comes coming in your mind. What? See, initially subarray starting from 1. Okay, and then we are moving just till complete. We are traversing the array. Okay. See, initially here 1 is constant, and we are completely traversing the array. Here 2 is constant, traversing the array. 3 is constant, traversing the array. 4 is constant, 5 is constant. That means if suppose let me take a pointer I, okay, and j. If both are equals to initially at 0, let me take I and j, both are at 0th index. Okay, and if I kept I constant till j traverse completely, then I make I moves here and j also moves here, and then I constant and traverse completely, and then I moves here, j moves here, and then traverse completely 3 4 3 4 5, and then I moves here, j also moves here, and then completely 4 4 5, and then I moves here, j moves here 5. Now tell me in the comment box what would be the uh, like how we will proceed. We will solve this problem in two ways. One is brute force solution. Second is optimal solution. Okay, in two ways. Let's see brute force solution. Why? Because to understand this thing, do this in O and time complexity. Do this in O and time complexity. What is O and time complexity? If you don't know what is time complexity, please watch my linear search video, only time complexity part. From there you'll get a clear cut understanding of what is time complexity, a good understanding. Okay, and wait till I publish complete dedicated video of time and space complexity after recursion. Okay, so there I'll explain complete thing. Okay, okay, for now let me explain you brief. O(n) means linear time complexity. Linear, see, time complexity means how my time growing as my input grows. Okay, now just see carefully. Okay, just focus here. What is n? N is size. What is O of n? Is time. N is size, O of n is time. Okay, and what is the relation? If we plot the graph, okay, suppose uh, if we plot the graph between n and time in seconds. Okay, n is the size. Okay, and if suppose the size of the array is 100, suppose size of array 100, so time should be 100 seconds. Okay, if we meet this, here is the point. If the size is 50, time should be 50 seconds. If the size is 1, time should be 1 second. Okay, so if we draw this, it's a straight line. Okay, it is a straight line. That means linear. That means if the size is 100, time should be 100. If the size is 1 million, time should be 1 million. So that is what O of n time complexity. O of n. N is the size, but O of n is the time. It should not exceed it. Okay, but our brute force solution will take O of n square time complexity. O of n square. That means if my size is 100, then time should be 100 square. That means 10,000 seconds, which is not allowed. We should have to write the algorithm which takes only 100 seconds if n is 100. But in our case, it will take 10,000 seconds. So it will give a big time limit exceeded error. Time limit exceeded error. Okay, we'll see a big time limit exceeded error. That is error. So that's why I have divided this problem in two ways. I can also show directly optimal way, but no. What is the use of this line? Do this in O of n. Use of this line is we will solve it first that brute force solution and then optimal solution. which is following this O of n time complexity. Okay, so let's come back here. Okay, so this is what the brute force solution. Now what is brute force solution? Simple thing what I explained you. What I explained you, take 2 pointers. Okay, take 2 pointers, fine. We have taken 2 pointers I and J. So let me do it on the next page. Okay, let me do it here. Take 2 pointer I equals 0 and J equals I. Okay, why? Because you can see initially I is at 1. Here in the past 1, I is at 1. Okay, and J is moving 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. If I is 2, then J is moving from 2 to 3, not 1, 2, 3. Okay, okay, so J is I initially, and then let move J to complete till length in a point. So initially we got one point that I is 0 and J is I. Okay, and J has to travel till complete array. So what it means? It means it is for loop 1, it is for loop 2. Fine. For loop int I equals 0 to n. Inside it for loop int j equals I till n, and inside it we'll check sum equals sum plus arr of I, and then if sum is greater than max, then max equals sum. Let initialize a variable max initially as 0 or integer minimum value. This is just a program done. Okay, don't worry if you haven't got it, then let me explain you in a brief. Fine. So what I have done here is, see here, first for loop, that is I, this is I, this is I. Okay, second for loop j. Okay, j has to traverse till I to end. Okay, so initially I is 0, j is 0. Okay, I have written sum equals sum plus arr of I. Okay, and initial value of sum is 0. That means sum equals 0 of what is arr of, not I, arr of j. Arr of j. Okay, arr of j, what is j? 0. So arr of j is 1. Okay, sum turns to 1. Here is sum. Okay, and now j has to traverse till I to n. Okay, next j plus plus. Okay, next j plus plus, fine. And then sum equals, now sum was 1, so 1 plus arr of j. What is arr of j? Now arr of j is 2, so 1 plus 2, that is 3, which is the sum of this. Fine, next this, next this, next this. Okay, and out of this we are just checking which is maximum. Fine, which is maximum, and then we are storing the maximum value of sum, and then terminating the loop. Then I move forward. Okay, we have already done this program, right? 2 for loop and checking which is maximum element. Find the maximum element, right? Same thing, find the maximum element, but in this case we have different passes. Okay, so for int I equals 0, I less than n, I plus plus, and int max is equal to 0, and sum equals 0. Okay, and suppose if this is the array 1, 2, 3, 4 and 5, and if you want to find the maximum, then you are calculating the sum. Okay, and then checking if sum is greater than max, then max equals sum. Okay, so at the end you will get max is equal 5. Okay, but this is just a pass 1. Okay, similarly for pass 2, pass 3, pass 4, pass 5, that's why we are using 2 for loop. One for loop is maintaining this first element from where j has to start, first element. Okay, and j maintaining traversing the loop and calculating the sum. So out of which sum, j is calculating the sum and also checking. So we are getting the maximum element and then we are returning it. Simple, program over. Yes, program over. See now here, it is inside for loop. Fine. So for loop I to n, for loop j to n. Initially for pass 1 it has calculated the sum and max value. Okay, then again for pass 2 it has calculated the sum and max value. Pass 2 till I reaches to n, it is continuing calculating sum max sum max sum max, and at the end it has find out the maximum value, and which is you want. Okay, if you see, if you are not getting, then I'll do the program. Okay, after this I'll do the program, and then I'll do with debugging also. Okay, we'll see like, okay, in pass 1 what the sum we are getting, in pass 2 what the sum, in pass 3 what the sum. Okay, so don't worry. Okay, now one thing, let me show you time complexity, the main game, time complexity. That is why we are not using brute force. Okay, time complexity. So very small thing is, see, we are using two for loop. One is for I, another for loop is j. Okay, see here, the ith loop, the outer loop is traversing n times. Are you agree? N means n can be 5. Here is n is 5. 1, 2, 3, 4, 5. Size times. So outer for loop is traversing till 0 to n times. Okay. Inner for loop also traversing till 0 to n times. So n into n equals O of n square time complexity. Okay. It is taking a huge time, like double, it's taking double. If we'll plot the graph between time and n, okay, if suppose n is 50, then it should take, then it is taking 100 seconds. Okay, so the graph will be like this. Okay, not this, this is the linear. Okay, but in n square it is like this, n square. Okay, it is a O of n, where this is the 50. Okay, but it is taking 100. N square, n square, n square, n square. Get my point? Now let's implement this code. Okay, let me open my Eclipse. Okay, so here I have opened my Eclipse, created the class maximum SubArray sum. Fine. Main method, and then the first thing is, let's create an array. Let's take the same elements what we have given in the problem. 34 minus 50. Okay, and let's create a method, get me maximum sum. Okay, let's pass the array. Okay, let me create this method returning integer, get me maximum sum, taking ARR. Okay, what we have done, two for loops. Okay, initially we have initialized max with integer dot min value. Fine, with the minimum value we'll compare. Okay, why I'm taking maximum value as an integer? See, integer or minimum value will give me the minimum value of integer. There is a range of integer. Okay, minus 2134, some big number, to plus 2134. So I'll take minimum value. Okay, initially, because see, in my array there are negative, positive, all the elements are there. Okay, so I'll take the minimum value of my maximum, and then I'll compare. Okay, if my sum will be 0, then I'll compare. Okay, if my sum will be negative, then I compare. Okay, we will see using debugging also. So this is what you need to clear. Int I 0, I less than ar dot length, and I plus plus. Okay, for loop int j is equals I j less than same ar dot length and j plus plus. Okay, now sum. Okay, we have not taken the sum, so we'll take the sum here. Int sum equals 0. Why here? See, first pass, let's calculate the sum and find the max. Okay, maximum found is stored in the maximum value. Another pass, we should not carry the old sum. Okay, another pass, we should not carry the old sum. In among them, we'll calculate the sum. If we'll got a maximum value greater than this maximum, then we will store it. Are you getting? Like suppose in this, suppose we have calculated the sum 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 0, 4, 1 plus 2 plus 5. Okay, so the sum was 9 and 12, 13, 14 and 15. If we carry the 15 here, then it will 15 plus 2, 15 plus 2 plus 3. Okay, but we should have to store individual maximum sum, sub-array sum. Okay, this individual sum is 2. If we carry 15 here, then it will be 15 plus 2, that is 17. No, it's sum, it's sum, it's sum, it's sum, it's sum. Okay, now it's alone sum. Okay, why? Now it's alone sum only happens when we put after pass 1 sum equals 0, then sum was 2, 2 plus 3, 2 plus 4, 2 plus 4, 5, sum 0, then 3. So in pass 1 all the sub array sum. Okay, in pass 2 all the sub array sum. Are you getting? Hope you are getting. Okay, that is why sum equals sum plus AR of I. Okay, we can also write it as sum plus equals, and then we are checking if sum is greater than max, then max equals sum. Return max. Okay, and here I'm printing what I'm printing, just printing the method. Okay, let's run it. First let me check anything is I0. Oh, here it is J, because J is traversing, right? So let me run it. Java application 137. What is the answer? 137. Okay, so see, this is a brute force solution. We got the answer. Okay, but not expected. Oh man. Where is my, yes, so the optimal solution is Kadane algorithm. Good scientist who has given the algorithm for this problem. Okay, let's see. Kadane algorithm, what it is. The array is given to us as 1, 2. Let's take different array. Suppose the array is given to us as -1, -2, 4, -2, 5, -1. Okay, now the cadence, just okay, I'll just clap. Okay, focus. The main point of cadence is star. We will not take negative element forward. We will not take negative element forward. Repeated number of times. See, this algorithm will giving you the sub array sum in just O of n time complexity. Okay, just repeat. There is only one formula. We will not take negative elements forward. Okay, rest all is similar to this only. This sum equals sum plus array, and then we are checking this. Just one more condition, and we are got the algorithm under O of n. Okay, so let's see it. What is it? Magic. So same thing, let's take int max and store it with a minimum value. Okay, and sum equals 0. Okay, same thing, max with the minimum value and sum is 0. Same thing. Go on. Next thing is, we are going to traverse from I is 0 till n. Okay, only one pointer I. There is no two for loop, one for loop O of n. One pointer traversing from 0 to n. Okay, fine. First element, where should I write? Let me write here. Okay, from here, first element is ARR of I, which is I is 0. Let me maintain I also. Where should I maintain I here. Initially I is 0. Okay, ARR of 0, which is -1. -1, add it. Sum equals sum plus ARR of I, which is -1. Sum is initially 0. Okay, 0 plus -1, -1. Sum becomes -1. Okay. Then check if sum is greater than max value. Initially max was the least integer. Okay, so yeah, -1 is greater than that. -2 1 we have seen. -2 1, the least range value. So yeah, -1 is greater than -2 1 something something. So max equals sum, which is -1. So let me maintain max also. Where I should maintain max here. Okay, here I'm maintaining already. So initially max was minimum value, now max turned to -1. Okay, similarly same thing. See, if sum greater than max, max equals sum. Okay, these two line is same only. Now the twist is, so sum calculated and sum greater than max, yes, so max equals sum. Max turned to -1. Okay, sum is -1, right? Yeah, sum is -1, sum equals sum plus AR of I, AR of I is -1, so sum is -1. Now this is first step, this is second step. Now we are checking if sum is greater than, not greater, if sum is less than 0. Sum is less than 0, follow this rule. We will not take negative elements forward. Okay, what is sum? Sum is -1, negative, less than 0. Yes, condition true. Turn sum to again 0. Okay, make sum again 0. Why? We will not take negative elements forward according to Cadence algorithm. We will not take negative elements forward according to Cadence. Okay, again turn sum to 0. Simple. This is iteration 1. Okay, loop ends I plus plus 1. Okay, ARR of I is equals now -2. Fine. ARR of 1 is -2. Again, sum is equals, so now sum is 0 only. Okay, we have turned 0 in the previous iteration. 0 plus ARR of 1, which is 0 plus -2, which is -2. Sum turns to -2. Okay, another step, if sum is greater than max. Now what is max? Max is -1. Sum is -2. -2 is greater than -1. See, it is negative elements. It is not 2 greater than -1. It is -2. So -2 is smaller. So if -2 is smaller, this condition getting failed. You can see now. If sum is greater than max. Okay. If sum is not greater than max, then this condition will fail. So max will not equal sum. Fine. So max will remain -1 only. Next, if sum is less than 0, sum is -2. Yes, again sum is less than 0. So turn sum to again 0. Again 0. This is second iteration. We can tell as pass 1, pass 2. Okay. Third iteration. I plus plus. I turns to 2. I turns to 2. Max is -1. Sum will again turn to 0. I is 2. Array is no, -1, -2, 4, -2, 5, 1. Okay, let me write it here only. -1, -2, 4. Okay. Yeah, 4 -2 5 1. 4 -2 5 and -1. I initially was here, now here. Okay, 0 1 2. I is 2. Same thing, same thing. What is ARR of I? ARR of 2 4. Okay, sum was 0, so 0 plus ARR of 2, that means 0 plus 4, 4. Okay. Next step, if sum greater than max, max was minus 1, 4 greater than minus 1, yes, then max equals sum 4. Okay. If sum greater than, then max is sum is 4. Now check if sum is less than 0. No, sum is 4, 4 is not less than 0. So skip this step. Okay, skip it. So now sum turn to 4, right? Sum is now 4. Sum will not put sum 0 because it is positive, not negative. So we will take positive forward. We will not take negative forward, but positive forward. Okay, pass 3. Good. Pass 4, 5, 6. Okay. ARR I. I turn to 2 to 3. Minus 2. Now here it's interesting. ARR of 3, which is minus 2. Again same step. Sum equals, now sum was 4. Okay, we have not changed it. So 4 plus ARR of 3, which is 4 plus minus 2. So 4 minus 2 is 2. Still sum is plus. Okay. Next, sum greater than max. Sum greater than max. No, sum was 2 and max is, see, sum turned to 2. Okay, max is 4. Max is 4. So sum is less than. So skip this step. Failed. If sum less than 0, no, sum is 2. See, we have encountered here minus 2. So initially sum was 4. 4 minus 2 is 2. Still sum is positive. If sum is positive, again skip this step. Only if we got negative, then no need to take. Just directly put 0. Okay, fine. Okay, fine. Yeah, so this is pass 4. Pass 5. Okay, pass 5. Pass 5 is, I is 3. Now I is 4. 4. Sorry, I is here. Okay. ARR of I, which is ARR of 5, which is 5. Right, 5 only. Now sum equals, initially sum was 2. So 2 plus ARR of 5, which is 2 plus 5, which is 7. Check sum is greater than max. 7 greater than 4, yes, then max equals sum, which is 7. Okay, sum is 7 and initially max is 4, so sum is greater than 4, yes, so max equals sum. Fine. If sum less than 0, no, 7 is not less than 0, so skip this step. Condition failed. This is pass 5. I plus plus 4 to 5. 0 1 2 3 4 5. Okay, now I moves at the end index. Okay, again last pass, pass number 6. Pass 6. Okay, ARR of 5, which is minus 1. Sum was 7, so 7 plus minus 1 is 6. Okay, sum was 7, now turn to 6. Max is 7, I is 5. Again check if sum is greater than max. No, sum is 6, but max is 7. Condition failed. If sum is less than 0, no, condition failed. Okay, return max 7. 7 is only the subarray sum, maximum subarray sum. Got it? Are you getting it? See, complete. This is what I know called as a debugging each and every step in pen and paper. Okay, we have debugged each and every step. Pass 1, pass 2, pass 3, pass 4, pass 5. Okay, I put this complete notes link in the description. Hope you will understand. Okay, this is much clear. Like 1, 2, 3, 1, 2, 3, 1, 2, 3 steps. Then this. Okay, how you're feeling? Just write in the comment section. Please comment down. Okay, it will encourage me to make this type of videos more. Fine. This is for Kadane algorithm. Okay, and it is following O of n. Why? Because we are just visiting the every element once. Okay, there is no two for loop. We are visiting every element once. That means If the size is n, then the iteration is n time. That means time taken is only O of n, not O of n square. Okay, O of n. Okay, let me implement this in code. So let me open my Eclipse. Okay, desktop. Fine. So this is brute force solution. Now cadence algorithm solution. Okay. Mm, okay, I'm calling get me maximum sub maximum sum using cadence. Okay, passing ARR. Copy this, creating this method int. Okay, int ARR. Okay, so let me take a long here. Okay, because the sum can be bigger. So long, there's no problem. Int long, the range differs. So int equals integer dot minimum value. Fine. For int I equals 0, I less than AR dot length, I plus plus. Okay, what is the first step? Sum, then condition, and then again some condition. Okay, so these two are the same, these two only. So sum equals sum plus ARR of, I can write the same thing, plus equals ARR of I, ARR of I, okay, and sum was 0, right? Okay, sum equals 0. Then if sum greater than max, then max equals sum. So let's take, no, max we have to taken, right? We are taking again. And then if sum less than 0, then sum equals 0. Okay, return sum. Fine. So we are not running this brute force, we are running cadence. Okay, so let's run it. Fine. So the answer of array, okay, this is the array we have taken. So answer of this array is 137. Okay, so I should get the same answer. Fine, from cadence also. 137. Getting, okay, fine. See only O and time complexity. Okay, okay. Now there's another thing. There's another, see, this is we have understood the cadence. Okay, now there's another thing question is asking us. What the thing is? The thing is, the thing is, see here, 4 is the number of elements present in the array. It is an array. Okay, it has given me another number, 1. So what it is? Okay, let me show you magic. So let us try on this array 273677. 273677. Okay, 273677. So 273677. So what will the maximum subarray? As it has not contained any negative, so all the summation, fine. If I run it, then 32. Yeah, 32. Fine. What is the answer? 14. Why? Because of this number. This number indicating, see, I have explained you complete parent. Okay, now from the parent, this is the parent program. This, okay, that calculate the maximum subarray sum. Parent program. Now, Microsoft, Google, Facebook, Amazon, Capgemini, Deloitte, and other top MNC companies will make some modifications. What are the modifications? That we don't want the maximum subarray sum. We want, but there is some modifications. What? What modifications? The subarray size equals this number. We want maximum subarray sum, and the subarray size should be 277 77 14. See here, subarray size should be 1. Only one element should present here. There is only a subarray. Subarray means an array only contains one element. Okay, so you need to find maximum. So 1, 2, 3, 4. 1, 2, 3, and 4. This is only the 4 possibilities which is following this condition. Okay, there are many subarrays, but a subarray which contains only one element is 1, 2, 3, 4. Maximum subarray 4. 4 is answer. Okay, so this is the modifications. Modifications, okay. There are many modifications in the same program. In the same program. That is why it is asked in Google and Microsoft. Okay, that is why it is asking Google and Microsoft. Google problem. You can see. Okay, so how to do it? Can you do it? See, I completely explained you parent. Now I want you to just yeah, just comment down. Okay, if you have done it, just comment down that comment down, no need to comment no complete solution. Okay, just comment down. Yeah, then mm, just comment down done. Okay, done with done child program. Okay, comment down this done child program. Okay, because I've shown you parent program. Done child program. Okay, and there is a small modification, or can I do it? Okay, you'll do it. Okay, fine. See, because I have completely, I'll not leave anything. But see, I'll not. Okay, I'll not leave anything. See, I have completely explained you using both brute force and cadence. See here, such a great explanation. I know this. Okay, pass by pass, pass by pass. Okay, previous in the brute force also. With time complexity, I'll not tell you anything. Just I want you to brainstorm, just a little bit brainstorm. We need to add one. We need to add one thing. Okay, like we need to just restrict it up to this k, whatever k m n n l o p. Okay, so this k. That okay, we don't want all subarrays. We want only the this specified length of subarrays, and then same process. Max sum, calculate sum, compare, return. Okay, so okay, so the hint is okay. So let me help you. Let me help you. Let me help you. So now extra int k. Okay, k means only kth subarray allowed. So pass k here. Okay, then fine. Pass k here. Okay, so here it is. We are getting k. Okay, count if count equals k, sum equals 0, count equals 0, count plus plus. Okay, done. Okay, see, I have just like giving you a hint, not hint. I've just shown you completely. You can do it yourself. See, just do it also. Okay, if anyone is failed to do it, then please comment down. Please comment down. I'll create this a separate video of. a 2 to 3 minute video that how to achieve this solution. Okay, so this is what all about this video, and yeah, so this is all about this video. Okay,